Kirk Math. All right, here we go. 9.5. We're in our student companion, page 206 to 207. We're learning another way to solve quadratic equations, which is called completing the square. So first we're going to learn visually what that means, completing the square. So the question is, we need to find the value of c right here so that this trinomial is a perfect square trinomial. And you might be saying, Ms. Kirkwood, I don't remember what a perfect square trinomial is. Well, that's why I gave you this diagram. So as a reminder, a perfect square trinomial is a three-termed expression that has a, basically I can turn it into a perfect square by it being the multiplication of two binomials that are identical. Right? So we have the binomial x plus 4. If I times x plus 4 by itself, I get x plus 4 squared. And if we FOIL this and multiply it out, I'm going to get a perfect square trinomial. A trinomial whose answer is a perfect square. Okay, so here we go, starting to make a visual of our shape here. So you can see that their equation x squared plus 6x plus c, well, we're going to move the c away for a minute and show what we have. So this is x squared, and then I have 6x's here. Okay, next what I'm going to do is split these two pieces apart, okay, because I'm actually going to physically make a square. So in order to make a square from a rectangle, I need to take some of these pieces and move them to the bottom. So because 6 is an even number, I put 3 to the right and 3 underneath my x squared. Now you have a wonderful partial square. This partial square has side length x plus 3 and x plus 3. But wait, there's a piece missing. That's why it's a partial square. So in order to find c, we need to figure out what fits here. Okay, now because I already know the side lengths of my square, I already know what the product of the two binomials or the square would be. That's x plus 3 squared. So what I need to do is figure out what c is. Now visually I can see that the green pieces are divided into 3 even parts. And this green is divided into 3 even parts. So that means that this little square, which is representing c, is a 3 by 3 shape. So its total is 9. Okay? And that's basically what I'm going to do. So this is x squared here. And then this is basically b divided in half. And my c is going to be whatever's left over to form the square. So here's my new trinomial, my perfect square trinomial. And let's look at this algebraically. So we did it visually, and what we need to do now is understand, well, how can I do this, with math? So completing the square is super useful when a quadratic expression is not factorable, because you might be saying, Ms. Kirkwood, why are we finding another way to solve quadratic equations? And the answer is because there might be a situation that those other ways aren't useful, and that would be when they're not factorable. So when you have a trinomial that's not factorable, we're going to use completing the square to solve, okay? So putting our formulas in like we did before, our blue square here is x squared, and then this is the half of b, each of these green parts. That means that c is b divided by 2 squared, because when I multiply them out here, and if I were to multiply and FOIL this out, I would be doing b divided by 2 times b divided by 2, which is b squared. So written as steps, the first thing you're going to do is take half of the b value and add it to the square root of x squared, which in this case is just x. Then this forms your square. When you multiply this out, you're going to get b divided by 2 squared, which means that c is the same as b divided by 2 squared. So this is something that you're going to need to remember. Okay? This is showing the trinomial, and this is showing the perfect square. So let's try it on a real problem. All right, so we are going to find the value of c that completes the square. So the first thing we're doing is we're going to take half of the b value. So I'm going to take 12 and I'm going to divide it by 2, and that is 6. And we're going to add it to the square root of x squared, which is just x. So I now know that the sides of my square is x plus 6 and x plus 6, or x plus 6 squared. Okay, so if I was drawing this out, this would be x squared, and then I've got 6 over here and 6 over here. So x plus 6 and x plus 6. What I need to do now is figure out what fills in my blank to complete my square. Okay, now I'm going to multiply this out, and I'm basically going to use this formula right here. I'm going to do b divided by 2 squared, which is 6 squared, and 36. So that means that the c value that completes the square is 36. My expression is going to be my trinomial, perfect square trinomial. It's going to be x squared plus 12x plus 36. So now you are going to try your own. So try B. Here are your steps. Let's see what you get. Okay. We have in example 2, we're going to actually use completing the square to solve a question. So you can see that this formula is already kind of in standard form, but this is unfactorable. I do not have 2 factors that can multiply to make 16, but add to make negative 14. So I can't just factor it out and use the zero product property like we did before. Instead, I have to use completing the square to solve my problem. So we're going to have some steps here. Write these down so that you understand what we're going to do. So step 1 is we're going to take the equation that's in standard form, and we're going to turn it into this format. Ax squared plus bx equals d. Now, I know it says d, and there's a reason for that I'll explain, but in reality, I'm really just moving the c to the other side, right? So we subtracted 16 on both sides, and that's how they got the x squared minus 14x equals negative 16, which matches this format. That's step 1. Step 2 is now to complete the square. So this is like what we did in example 1. We're going to use this formula right here, b divided by 2 squared, to get the c. This is that missing c to make a perfect trinomial. And then we're going to add it to both sides. So they added 49 to the left and the right, and they got x squared minus 14x plus 49 equals 33. All right, step 3 is now to write the trinomial as a binomial squared. I can do this because my c value I know is going to be a perfect square, because in order to find it, we had to square. And so it's always going to be a perfect square here. So all you have to do is find the square root of c, which square root of 49 is 7, because we have a negative sign here, but a positive sign here. My sign in between my my binomial squared is going to be minus. So this is x minus 7 squared is equal to 33. Now I can jump down to step 4 and solve for x. Now the reason I'm trying to write a binomial squared is because we can start applying what we've done in other lessons and do the square root of both sides in order to solve. So the square root leaves me with x minus 7 equals positive or negative square root of 33. I'm now going to add 7 to both sides to get x alone. And here's my answers. 7 plus the square root of 33 and 7 minus the square root of 33. Okay, and that's how I took an unfactorable, you can do it with any trinomial, but unfactorable trinomial, and found the solutions, the x values. So let's do another one together. So here are my steps, and I'm going to follow them. So first, I'm going to write it into this format. Whoopsie, that should be a plus. So that means I'm going to add the 9 to both sides. Okay, so x squared plus 10x equals 9. Okay, now I'm going to complete the square because I need to find a new c. I need a c value because I got rid of it and turned it into a d value. Okay, so to complete the square, I'm going to do 10, my b value, divided by 2, and squared. 10 divided by 2 is 5, so that answer is 25. I am now going to add that value to both sides. So this becomes x squared plus 10x plus 25 equals 25 plus 9 is 34. Now I'm going to write the trinomial as a binomial squared. So we're going to square root this, and I'm going to get x positive this time because both of them are plus 5 squared equals 34. Now I am going to solve for x. So I'm going to do the square root of both sides and get x plus 5 equals positive or negative the square root of 34. Subtract 5 from both sides, and I'm going to write my answer up here so you can see it better. I get negative 5 plus or minus the square root of 34. Now, here's my answer written in two different equations. So negative 5 plus the square root of 34, negative 5 minus the square root of 34. So go ahead and try it yourself. Now on example 3, you're not going to do the try it. I just want to show you what happens when a is not equal to 1. Because we've been doing formulas that have a equal to 1. But what happens when I have another coefficient that's not 1 in front? Okay, so basically because this is unfactorable, I'm going to complete the square, and I am still going to put this in the x squared plus bx equals d format. Okay, so they added the 16 to both, or subtracted 16 to both sides, and that's how they got here. But because I want this to look exactly the same, I'm dividing each side by that coefficient, which is 2. And that's going to get rid of the a value that is not equal to 1 and turn it into one that is equal to 1, right? So basically, I'm canceling these out so that I can get something that looks like this. Because from here, I should be able to do what we just did in the last example, okay? We should complete the square by adding the 6 divided by 2 squared to both sides and then solving for x. And you end up getting about 50 and negative 56 as your solutions. So we're not going to practice this one. It's just kind of showing you that when you have a problem that you want to use complete the square with, but it has a coefficient other than 1 for x squared, then all you got to do is divide by that coefficient to make it work out. All right. For example 4, the last thing we're going to do is talk about how do I use completing the square to take a formula in standard form and write it in vertex form. So remember that vertex form is this: a times the quantity x minus h squared plus k, where the h and the k are our vertex, okay? Now remember, we always used to just say the opposite of h and k because this little negative right here always confuses us, but it's the same idea, okay? We are going to use completing the square to find this piece right here, okay? Which is right there. That's what we're going to do. So here are your steps. I have my problem. Okay, I'm going to start to rearrange my problem to isolate this. I want x squared plus bx. So this right here, I want to be by itself. So what they did was subtract 11 on both sides. Okay, and then they completed the square. So they did negative 8 divided by 2 squared to get 16, and they added that to both sides. Okay. We now have something that looks very similar to vertex form. All I got to do is move the 5 back to the other side so it can become k. So they subtracted 5 from both sides, and you're done. Okay, here is your formula in vertex form. All right, let's try it together. So, like we said, I want to get it into this format, bx. That's the first step. So I'm going to subtract 3 on both sides. So I'm going to get y minus 3 equals x squared minus 2x. Okay, now I'm going to complete the square. And I'm going to pause to do this because we're running out of time. So completing the square got me here. And now I'm going to write this as the binomial, a square binomial. And now the last thing I'm going to do is move this back over so I have a K. All right, and there is my answer.